Alright, another day, another problem. Basahin natin tong problem na to. Consider a river flowing toward a lake at an average velocity of 3 meters per second at a rate of 500 cubic meters per second at a location 90 meters above the lake surface. Determine the total mechanical energy of the river water per unit mass in joules per kilogram and the power generation potential of the entire river at that location in megawatts. So, pinapahanap sa atin in this particular problem the total mechanical energy of the river water per unit mass. So, that is specific mechanical energy. Basically, ano nga ba si mechanical energy? Mechanical energy is the energy an object has because of its position and its motion. Energy to dahil gumagalaw siya o dahil nasa certain position siya. So basically, mechanical energy is what? It is the summation. Mechanical energy is the sum of the potential energy and the kinetic energy of a body or system. Since it's per unit mass, again in thermodynamics, kapag per unit mass, we write it in small letters. So this is specific mechanical energy. This must be specific potential energy plus specific kinetic energy. So what are we given? We are given velocity, elevation, and we are also given 500 cubic meters per second. So what is that? That is a volume flow rate. So let's write our given values. We have our velocity, which is 3 meters per second. We also have our elevation Z, which is 90 meters. And we have our volume flow rate. It has that symbol kasi it's per unit time. It's a rate, it's in rate form. That is 500 cubic meters per second. So, ito yung mga given natin. So, again, we are asked to find the total mechanical energy per unit mass or specific mechanical energy. So, we will simply use our formula. So, let's proceed. Our total mechanical energy per unit mass is, anong formula ng potential energy per unit mass? That's mgz, but it's per unit mass, cancel lang yung mass. So, we have gravitational acceleration times the elevation plus 1/2 mv squared for kinetic energy, pero it's per unit mass, cancel lang yung m, so we have 1/2 v squared. So using this formula, we can solve for our mechanical energy. So inputting our values, since we are in SI, it's in meters and seconds, we can use the gravitational acceleration of 9.8066, that is in meter per second squared, multiplied by the elevation, 90 meters, plus 1/2 times our velocity squared, which our velocity is 3 meters per second. Yan. But as you can see, both of them will arrive with the unit of meter squared per second squared kasi itong m tsaka m na to ay magmumultiply. Tapos itong squared ay madidistribute dito tsaka dito. And dun sa 3. So, hindi pa siya unit of energy. Hindi pa siya joules per kilogram. Ang gagawin ulit natin, take note, yung palagi natin ginagawa, napakahalaga na we are familiar with the necessary conversions or factors. Note that 1 Newton is equal to kilogram meter per second squared. And again, kung nagtataka kayo kung saan nanggaling to, that is just from Newton's second law, which is force is equal to mass times acceleration. This is the mass, this is the acceleration. So, dun lang nanggaling yan lahat. So, we can use that factor to convert this to joules per kilogram. So, let's just add a bracket dito para isang multiply na lang sa parehong terms. So we can put it here. We know that 1 Newton is equal to 1 kilogram times meter per second squared. And from here, we can see that our units will simply cancel out. Diba meters per second squared to? Cancel yung isang meter. Tapos cancel din yung isang meter dito kasi madidistribute siya dyan, madidistribute siya doon. Magka-cancel lang. So, may matitirang isang meter dito. Tapos yung second squared, magka-cancel lang din. So, cancel yung second squared. Let's write it para ano. Yan. Okay, cancel yung second squared. We will be left with Newton meter per kilogram. So, pressing that into your calculator first, you'll arrive with the answer of 9.8066 times 90 plus 1/2 3 squared. We have 887.094. So, 887.094. And again, since na-multiply natin just sa factor na to, we'll have the unit of Newton times meter per kilogram. And we know that 1 Newton meter is equal to 1 joule. 1 joule. Yan. So, basically, we're successful. Nagawa natin siyang joules per kilogram. Again, it's all about unit analysis. Napakahalaga ng units in thermodynamics. So, master the units. Yan. So, this is our total mechanical energy per unit mass in joules per kilogram. Right. But, you're also asked to find the power generation potential of the entire river at that location in megawatts. So, let's remember this formula. Yung energy in rate form is equal to the mass flow rate times the type of energy present. So, for this particular problem, the energy present, kasi may motion and certain elevation, yung energy natin dito is mechanical energy. So, we can say that the power generated, anong pinapahanap? The power generation potential. Diba, alam natin that when we have this symbol, it's per unit time. And we know that power is equal to energy per unit time. Or simply, energy, tas may symbol na ganon. So, we can replace this with power. So, the power generation is equal to the mass flow rate times the energy present, which is mechanical energy for this particular problem. So, we can write as P is equal to mass times P is equal to the mass flow rate times mechanical energy. Yan. You can determine the power generation. So, but are we given the mass flow rate? No. Walang mass flow rate na given sa problem. Pero may given na ito, yung volume flow rate natin na 500 cubic meters per second. So, let's write that down. Our volume flow rate is equal to 500 cubic meters per second. Wala tayong mass flow rate. Saan natin kukunin si mass flow rate? Remember, note that, remember the formula for mass flow rate. Anong formula ni mass flow rate? Mass flow rate is equal to the density of the substance or fluid times the volume flow rate. So, rearranging this formula, this equation, we can simply solve for mass flow rate. Pero ito na pala yun. Mass flow rate is equal to the density times the volume flow rate. Ang problem, meron na tayong volume flow rate. Problema na lang natin is si density. Looking back at our problem, makikita mo na river water. So, ang density na involved is density ng water. And again, the density of water in SI is simply 1,000 kilogram per cubic meter. So, we can say that the power generation, since it's equal to the mass flow rate times the mechanical energy, since it's the energy involved in this problem, substitute natin ito kasi equal siya sa mass flow rate, palit mo lang siya doon sa mass flow rate doon. So, we will have the density of water times the volume flow rate times the mechanical energy na nakuha natin kanina. So, anong gagawin natin sunod? We will simply input our values. So, let's proceed. The power generation is equal to the density of H2O, which is simply 1,000 kg per cubic meter. Do not forget to write the units kapag nagsasolve kayo. Dapat laging may units para ma-check nyo kung tama yung sagot nyo, okay? So, our volume flow rate naman is, salpak mo lang, 500 cubic meters per second. And yung mechanical energy na nakuha natin kanina is 887.094 joules per kilogram. Write it down. Joules per kilogram. Now that we've written all the necessary values, mag-unit analysis tayo. Shing, shing. Tapos itong kilogram at kilogram, cancel din. Shing, shing. Anong natira? Joules per second. But first, let's press the numerical values to our calculator. 1,000 times 500 times 887.094, we have, ang laki ng value, 443,547,000. 443,547,000. So, 443,547,000. And we are left with the value, with the units of joules per second. And again, since thermodynamics is sa puso nyo na that energy per second or joules per second in SI, this is equal to watts. So, we can write 4,457,000 watts. But again, lagi kayo magbabase sa hinahanap sa problem kasi each problem is looking for a certain value with a certain unit. So, ang hinahanap is in megawatts. So, simply, gawin lang natin siyang megawatts. We know that 1 megawatt is equal to, ano yung prefix na mega? Mega is equal to 10 raised to 6. So, 1 megawatt is equal to 10 raised to 6 watts. So, pressing this into your calculator, the total power generation sa ating river is equal to 443.547. 547, that is in megawatts kasi this will be shing. So, ang natira sa ating unit is megawatts. So, this is our final answer for this problem. Ito yung total power generation and ito naman yung total mechanical energy in joules per kilogram. Again, napakahalaga ng units and necessary conversions and formulas katulad ng mass flow as well as the prefixes. Let us now solve this problem. So, basahin natin. Water is being heated in a closed pan on top of a range while being steered by a paddle wheel. During the process, 30 kilojoules of heat is transferred to the water and 5 kilojoules of heat is lost to the surrounding air. The paddle wheel work amounts to 500 Newton meter. Determine the final energy of the system if its initial energy is 12.5 kilojoules. So, ano yung mga given natin? Tingnan muna natin na, okay? So, ang mga given sa atin, first is water is being heated in a closed pan stirred by a paddle wheel. During the process here, 30 kilojoules of heat is transferred. So, ibig sabihin, may pumasok na 30 kilojoules of heat sa system natin. May na-add na 30 kilojoules of heat. So, kapag nag-add ng heat, ano nga ulit sign convention natin for addition of heat or heat entering our system? Q is positive. So, lagay natin Q in kasi pumasok yung heat or nag-transfer sa system natin. So, we have 30 kilojoules. And 5 kilojoules of heat naman is 5 kilojoules of heat is lost to the surroundings. Ibig sabihin, may nawalang 5 kilojoules of heat or 5 kilojoules of heat left our system. So, kapag umalis sa system o nag-reject or nag-loss ng heat ang system, lagay natin Q out kasi lumabas. So, this will be negative 5 kilojoules. Again, mahalaga yung sign convention. Pag dumagdag sa system, positive. Pag nawala or nag-reject is negative. And then, the paddle wheel work. May sinabi ng work. Work amounts to 500 Newton meters. So, nag-apply tayo ng work during the process. So, itong 500 Newton meter or 500 joules kasi 500 kasi Newton meter is equal to joules ay papasok sa system kasi nag-apply tayo ng work. The paddle wheel applied work dun sa system. So, this will be what? This is work na pumasok or work sub in. Pumasok na energy in the form of work. So, that will be 500 joules. Pero, again, remember that in solving thermodynamic problems, kailangan consistent lahat ng units mo. Ito ay naka-kilojoule, 30 kilojoules, plus negative 5 kilojoules. Mas maganda na gawin mo ng uniform lahat ng units. So, gawin na lang natin silang kilojoules lahat. So, 500 joules ay equal sa 0.5 kilojoules. Dinivide lang natin siya ng 1,000. Okay? So, we are asked to determine the final energy of the system if its initial energy is 12.5 kilojoules. So, meron tayong initial energy na denote that by E sub I kasi initial 12.5 kilojoules yung initial energy sa system natin. So, meron tayong Q na pumasok, Q na lumabas, work na pumasok, and initial energy. So, for this problem, anong gagamitin nating formula? We will use the formula for the energy balance equation. But before that, para mas madali nating makita, again, our required na pinapahanap sa atin is yung final energy or E sub F. Para mas madali nating ma-visualize, let's draw. Kunyari, meron tayo, ito yung system natin. Kahit anong shape, bahala na kayo. Tapos, merong pumasok na Q in. Tapos, may pumasok na work. Alright. Tapos, may lumabas na heat. Q out. Okay. This is our system. Okay. So, we will use the formula for the energy balance equation. Ano ang formula ng energy balance? We have the energy in, lahat ng energy na pumasok, minus energy na lumabas, ay equal sa net change in total energy or the final energy minus initial energy. So, makikita natin dito na may dalawang types of energy na pumasok, which is heat and work. So, we can say that lahat ng pumasok na energy ay Q in plus work in, work na pumasok, minus yung energy na lumabas. Ano yung energy na lumabas? So, that is Q out. May heat kasing na lost or na wala sa system natin. So, yun lang yung lumabas. Ito lang. This is yung pumasok. And ito yung lumabas. The energy that entered and the energy that left. Yan. Para hindi kayo malito. Okay. Tapos, meron tayong final energy and initial energy. Ang pinapahanap sa atin dito is yung final energy. Ako, personally, ang ginagawa ko bago ako mag-input ng values, minamanipulate ko muna yung mga variables para pag pindot ko, yun na yung sagot. So, let's solving for the energy in the final state. We have transpose lang natin tong initial energy papunta doon, that will become positive. So, we will have Q in plus work in minus Q out. This will become plus energy in the initial state. So, meron naman tayo lahat nito. So, we will simply input them and press that into our calculator. Ano yung pumasok na heat? 30 kilojoules. Yung work applied or yung work na pumasok is 0.5 kilojoules. Tapos meron tayong work na lumabas which is negative 5 kilojoules. Again, di ba may negative na dito? Tapos yung Q out natin dito ay negative 5. Hindi mo na siya gagawing minus negative, hindi mo gagawing ganyan. Kasi itong nandito na negative 5 just indicates na palabas yung heat. So, we will just input ito na mismo. So, minus negative 5 kilojoules. And then, plus our initial energy, which is 12.5 kilojoules. Alright, so pressing that into your calculator, your final energy in the system is 30 plus 0.5 minus 5 plus 25, that is equal to 38 kilojoules. Again, dapat uniform yung units para hindi ka magkamali sa computations mo. Okay, this is our final answer for this simple problem. Now for this problem, basahin natin. An adiabatic closed system is accelerated from 0 meter per second to 35 meter per second. Determine the specific energy change of the system in kilojoules per kilogram. So, meron tayong adiabatic closed system. Pag sinabi nating adiabatic, ano nga ulit yun? Adiabatic means no heat transfer. Walang nangyaring heat transfer kapag adiabatic. Tandaan nyo na yun. So, it is accelerated from 0 meter per second to 35 meter per second. Ang hinahanap, the specific energy change of the system. So, walang sinabi kung anong type of energy. But, based from our given, base sa mga given sa atin, meron tayong initial velocity at final velocity. From 0 meter per second, naging 35 meter per second. So, we can say that our initial velocity or V sub 1 is 0 meter per second and V sub 2, our final velocity, is 35 meter per second. So, we can conclude na yung energy present, yung sinasabi niyang specific energy change or delta E, is just the change in what? Kapag velocity ang involved, it is the energy of a moving body, we have kinetic energy. But specific energy change kasi we have an initial and final velocity. So the specific energy change of the system is a change in its kinetic energy. So pinapahanap siya sa atin in what particular unit? In kilojoules per kilogram. So you will simply use the formula for the change in kinetic energy. And it's per unit mass kasi specific nga. So, again, kapag energy change or change, it's final minus initial. So, that will be 1/2. Factor out na natin yung 1/2. So, we have V sub 2 squared minus V sub 1 squared. So, basically, the final velocity squared minus initial velocity squared times 1/2. So, yun lang yun. So, inputting our values, we have 1/2 times 1/2 tapos V2 is 35 squared minus V1 which is 0. Pwedeng hindi mo ilagay pero in this case, lagay na natin. Tapos, yung units, ilagay ko na lang dito sa labas. Kasi pareho naman sila, para hindi na natin sila ilagay separately. So, ang unit dyan, magiging unit dyan Kasi madidistribute tong squared, this will become meter squared per second squared. Kasi ganito yan eh. Di ba meter per second, tas naka-squared. So, distribute lang yung 2. So, yan yung magiging units. But, again, hindi pa siya joules, hindi pa siya kilojoules per kilogram. Atin mo nang pindutin to sa calculator. So, 1/2 times 35 squared, that is equal to 612.5. Ang unit ay naka-meter squared per second squared pa. Tapos, convert na lang ulit natin using the factor. Lagi nyo nang tandaan, 1 Newton is kilogram times meter per second squared. So, using that factor, we can convert that to joules. So, this will become, again, 1 Newton is equal to 1 kilogram times meter per second squared. Tapos, unit analysis, canceling out the units, shing, may matitirang isa. This will become Newton meter per kilogram, and we know that Newton meter is equal to joules. So, our resulting unit is equal to 612.5 joules per kilogram. And making that kilojoules, we know that 1 kilojoule is equal to 1,000 joules. Our specific energy change for this problem, which is in the form of kinetic energy, is simply 612.5 divided 1,000. That is 0.6125. 6125. Kasi, tapos kilojoules na yan. Kasi, cancel lang tong joule. Shing. Alright. Okay. Sana na-gets natin yon. So, mga basic problems pa lang to. Again, master the basics. Kasi ito yung magdadala sa inyo para maintindihan nyo yung more complicated problems along the way. Let us now proceed answering this problem. So, first up, basahin natin. A vertical piston cylinder contains water and is being heated on top of a range. During the process, 65 BTU of heat is transferred to the water, and heat losses from the sidewalls amount to 8 BTU, or British thermal unit. The piston rises as a result of evaporation, and 5 BTU of work is done by the vapor. Determine the change in the energy of water for this process. Again, para mas madali nating matandaan or ma-visualize, mas maganda na gumawa tayo ng diagram. So, meron tayong system. Yan, kahit anong shape, bahala kayo sa drawing. Tapos, in our system, based on the problem, during the process, sabi dito, during the process, 65 BTU of heat is transferred to the water. So, may pumasok na 65 BTU of heat. And again, BTU stands for British Thermal Unit. And it is a unit of energy in the English system. So, may pumasok na heat, Q in, which is 65 BTU. Sa side na to, lagay natin lahat ng nag-enter. And sa side na to, lahat na lumabas or the energy that left the system. So, may pumasok na heat sa system. This is our system. And heat losses, may nawalang heat from the sidewalls, amount to 8 BTU. So, may nawalang amount of heat or Q sub out para indicate na lumabas. So, we have 8 BTU na lumabas. Oops, dito natin lagay pala sa kabilang side kasi lumabas nga siya sa system natin. So, may lumabas na heat which amounts to 8 BTU. The piston rises as a result of evaporation and 5 BTU of work is done by the vapor. Ang sabi, kasi nga nag-evaporate yung water, tumaas daw yung piston, and as a result, 5 BTU of work is done by the vapor. So, ibig sabihin, 5 BTU of work is done. So, our system made or produced work. So, saan natin siya lalagay? Nag-enter ba siya? Or lumabas sa system? Kasi nga, nag-apply tayo ng heat our system made 5 BTU of work. So, dito natin siya ilalagay sa lumabas. So, dito, sa side na to. So, lagay natin na workout. Kasi nakalagay naman dyan, work is done by the vapor or by the system. Hindi naman, work is done on the system. So, hindi pumasok yung work, kundi nakapag-produce tayo ng work. So, lagay natin dito, works about, that is 5 British thermal unit. Okay. So, ayan, madali lang yung problem na to. We will simply use the anong formula? Energy balance equation. So, using the formula of the energy balance equation, lahat ng energy na pumasok minus lahat ng energy na lumabas ay equal sa change in the net change in energy. Kasi pinapahanap sa problem na to is determine the change in the energy of the water for this process. So we are simply looking for the net change of energy during the process. So ano yung energy na pumasok? Isa lang, Q in, minus yung energy na lumabas, dalawa. May heat na lumabas at may work na na-produce yung system. So, we have here 8 Q out at lumabas din yung work nakapag-produce kasi. And that is equal to the net change, which is what we are looking for in this problem. So, this problem is pretty basic. We will just input our values. Our Q in is 65 BTU minus Q out na 8 BTU minus 5 BTU. So simply, that is 65 minus 8 minus 5, that is equal to ilan? 32, 52 pala. 52 British thermal unit or BTU. So this is the answer for this problem. Again, master the basics. Madali lang yung problem na to. You just have to understand the principle of the energy balance equation. Alright? And yung sign conventions kapag pumasok at lumabas sa ating system. Okay?